So if you remember what A plus B, if you remember what was A plus B squared, the coefficients were 1, 2, 1. If you remember what was A plus B cubed, the coefficients was 1, 3, 3, 1. Okay? So this first method of getting nCr, which is this function here, nCr, is known as Pascal's triangle. Right? So if we had, let's squeeze in the thing here, if we had A plus B to the 1, then the coefficients will be 1 and 1. That's okay? This, what we're going to set up now, is something called Pascal's triangle, and it's the first method of actually trying to work out these values. Okay? So let's take a look at how it sets up. So Pascal's triangle. Right? Let's squeeze in A plus B to the 0. Anything to the power of 0 is 1. So here's how it works. So suppose we wanted, okay, well, what is A plus B to the power of 4? What we do is this. Instead of having to go and work it out along with what we just did, we could use Pascal triangles. And here's how Pascal triangle operates. It starts at 1 and it's always 1s on the outside. So we have 1 here, 1 here. Make it a little bit. 1 here, 1 here. Okay? How do we get this value here, the second value? The second value is simply, you can see it here. This is a better example. You can see it here. This value is always the sum of the two values above it. So the sum of these two is this. Look at 3. The sum of 3 is these two here. See that? Right? Same thing here. The sum of these two gives it 3. So the value here will simply be the sum of 1 and 3, which is 4. What will be the next value here? It will be a sum of this and this. 3 plus 3 is 6. Next value here, 3 plus 1 is 4. Same pattern. So this here represents the coefficients of all the terms in A plus B to the power of 4. Right? So how does this help me find nCr? Right? So let's say I wanted to find, so 4C3. Right? So we have 4C1, 4C2, 4C3, 4C0. So I'm going to write it here for you. This will be 4C0. This will be 4C1. This will be 4C2, 4C3, and 4C4. See that? So what we have here is that we have 4C1 being 4, 4C2 being 6. So you go to the calculator, check it just to make sure. 4C3 being 4 and so on. Okay? So this is one of the ways of working out Pascal triangle. Using Pascal triangle to find nCr. But of course you can see the problem. Imagine having to find something like this. 15C2. You'll have to go all the way down. My board can't even hold it. Right? To find this value. So the triangle has to keep going on and on and on. So there's a next method to find functions like this, which I will show you in a little while. Right? Let's just continue and let's go about C6. Make sure you catch a pattern. Right? So let's do A plus B to the 5. Give that a quick minute. Do it fast. Right, minute up. So you put the 1s on the outside. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. Do one more. A plus B to the 6. Put the 1s on the outside. And you go. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. Plus this is 6. See? And if you look at it carefully, you have a nice little triangle. Okay? So this is Pascal's triangle, and this will give us, for example, 6C1, 6C0, 6C1, 6C2, and this, for example, will be 6C3. 6C1, 6C0, 1, 2, 3, 4, 4, 5, 6. Okay? So good. So this is Pascal triangle, right? Now we're going to take a look at using the actual formula. Right. So nCr. So there's a formula that gives us nCr. nCr is equal to n factorial over n minus r factorial r factorial. So you might be wondering now, what is this factorial thing? Right? And it's very simple. What is factorial? Factorial, for example, n factorial is simply multiplying all the terms from 1 to n. Okay? So for example, what is 3 factorial? 3 factorial is all the values from 1 until n, which is 1 by 2. In this case, n is 3. So 1 by 2 by 3 is 6. Try next one. 4 factorial. Same thing. 1 by 2 by 3 by 4. So from 1 until 4. This is 2 by 6 by 4 is 24. We do one more. 5 factorial. 1 by 2 by 3 by 4 by 5. Which is simply 24 by 5. Right? Which is 120. Okay? So this is what factorial really is. Right? You simply multiply from the first term to the n term. Right? To find a product of all these values. Okay, so let's go back to finding nCr now. So nCr. So let's say now we wanted to find, you'll remember what was 6C3? Let's see if we can find 6C3. So 6C3. So 6C3, as far as we are looking in our table, was 20, I think. 20. Right? So 6C3. So that will be n is, so we're looking at it, n is 6 and r is 3. So 6 factorial over 6 minus 3 factorial. R factorial is simply 3 factorial. So this is really what? 6 factorial over 3 factorial by 3 factorial. So we could work it out. 1 by 2 by 3 by 4 by 5 by 6. And this is 1 by 2 by 3 by 1 by 2 by 3. Okay? So, what we'll end up with here, this is 120. 120 by 6 is 720 all over 1, 2, 3 is 6 by 6 is 36. Right? If we simplify this, we should get 20. Good? And that's why you simplify it, because since they are products, we could cancel this by this. And 2 into this is 2, 3 into this is 2. 4 by 5 is 20. Very good. Right? So that's the way we work out factorial. 6C3, 20, 20. That's okay? So there are many more examples that you could try. Try using the calculators to make sure you get this value. Okay? So when n is less than 0, or n is a fraction. Right? So example, if we have to get, let's do something simple, a half C2. How are we doing that? Well, it's fairly simple. It works like this. A half, which is this value here, by a half minus 1 all over 2 factorial. Where does that come from? Well, the rule looks something like this. What is nC3? nC nC2 is n by n minus 1 all over 2 factorial. What is nC3? Well, there's 3 terms now, right? So it'll be n by n minus 1 by n minus 2 all over 3 factorial. So what will be nCr? N by n minus 1 by n minus r minus 1, because this value here is less than that, all over r factorial. And this version is only really used when we have a fraction or something negative. Because if you wanted to find, for example, a half factorial, we wouldn't get it from our calculators, nor 2 factorial, minus 2 factorial. Okay? So let's see if we could work it out. Right? I'll leave this one up here. So we'll end up with what? A half minus 1 is minus a half. 2 factorial is 1 by 2. A half by minus a half is minus a quarter all over 2. A quarter divided by 2 is minus 1/8. That's okay? Let's do a next example where it's negative. So negative 3. Right? Negative 3. Follow this? Let's do negative 3 now. So we follow the rule. It will be, so always remember, if it has a 2 here, it means you're going 2 terms. If it has a 3, you're going 3 terms. Okay? So you go negative 3. So this could be our term if you want to simplify it like that. So it will be negative 3 by negative 3 minus 1. We're doing 2 products. So this will be the R product. Okay? So it will be negative 3 by negative 1 all over 2 factorial. So it will be negative 3 by negative 4 all over 1 by 2, which is negative 12 over 2, which is negative 6. So that's the way we will use nCr. Right? Remember, if it were 4 factorial, then it should have 4 products on top. So it will be minus 3, minus 2, that's 1, 2, 3, one more, minus 3, minus 3. So that will be minus 3 by minus 4 by minus 5 by minus 6 all over 1 by 2 by 3 by 4. Okay? 4 will cancel, 3 will cancel, 2 into this is minus 3, so the answer is minus 50. Very simple. Very, very simple working. Okay?